Hello, my name is Ahmad Aizat Abadi bin Abdul Hadi and my friend Muhammad Rizal bin Zazi, also Muhammad Lokman bin Yusuf. Today we will presenting our high voltage technology laboratory entitled Introduction to High Voltage Lab in FTKEE.
Trace lamp and alarm circuit. Okay. First picture is auxiliary terminal lamp and horn. Second is the cage, and thirdly is the lamp horn. Okay. Trace lamp and alarm circuit is used for safety. Every cage have the trace lamp and alarm circuit and connected to the auxiliary terminal lamp and horn terminal for safety case. When the red light is active, the injection or testing process cannot be processed, and when the green light is active, it is safety to proceed the injection or testing process. Okay, after this is trace interlock system. Okay, this is the overall. This is the flow of the interlock connection. Okay, the interlock connection goes to the part of the outlet unit, after which the outlet unit is connected to the sensor near the door. Okay. Interlock is used to monitor the door to the high voltage part of the system and to monitor if the ground rod is taken out from the high voltage. It can also be a door in a safety fence mounted around the HV part. During the testing process, if the door is open, the injection or testing process will not be possible because the red color alarm will always live in the system. And when the door is closed, the injection or testing process can be processed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lokman bin Yusuf. I'm now going to explain about the task 1. Task 1 is about how to trace the power cable circuit. To trace the connection of the power cable, it starts with the power isolator and will be connected to the power cable. In the power cable, they have brown, black, grey, green, yellow is for earthing, blue is for neutral, and it will continue connect with the power block terminal and will be terminate in it. In the power block terminal, they have two sections. There's bottom connection and top connection. At the bottom connection, we connect the 5 core that is named as earlier, and at the top of the power block terminal, there are 3 black cable. Those 3 black cable, 2 will be connected to the internal transformer, and the other one will be connected to the current transformer. There are 4 cable that coming up from the internal transformer. The 4 cable will be connected to the out terminal block. The cable, there is 2 black and 2 yellow. Okay, now I will talk about the circuit diagram that is in the FC kit. Okay, now as we can see, there are 3 color. There is red, yellow, and blue cable. PE is for earthing and neutral is for neutral. All of the 3 cable must be connected to the ground. As you can see, there's 2 ground over there, and at the red cable. There and on the red and blue cable there will be attached a transformer. This circuit is consists of 50 to 60 hertz, and it infeed of 500 volt. Now I will talk about the emergency stop button. There are two emergency stop button port at the side of the kit cabinet frequency converter. If there is another option, we can also use the delivered hearting plug with 6 pins that can connect to our own emergency stop button. As we can see at the circuit, the emergency stop button will control two normally closed contact that is used, and it will work with dual channel operation. As you can see, there have been marked the two normally closed contact. Next, this process will monitor the discrepance time between two contacts and has a cross-shot detection to prevent both from connecting together in a fault case. As you can see at the second at the right circuit at the right, the switch is being opened and the circuit is now cut from voltage to flow. There must be at least one emergency stop button has to be connected in the circuit. That's all for me. Thank you.
So I will continue with the main grounding chamber, which is outside of the high voltage lab, and it's grid at each grounding terminal cell and grounding terminal cell to the frequency converter. The main grounding chamber, as you can see here, the main grounding chamber outside of the high voltage lab is being meshed or looped, as you can see here. The grid at each grounding terminal has their own grounding, which means they cannot be the same with the building grounding, as you can see here. According to the kit heavily, to avoid ground loop between different grounding points, the kit is grounded at only one position to a ground rod. The rod must have ground resistance of less than 2 ohm. Hence, all of the instruments will connect to a special grounding, and the special grounding must meet the groundwater. Under the wet condition, we can get around below 1 ohm, while under the dry condition, we can get around below 2.5 ohm. According to IEEE, if grounding is below 5 ohm, it is acceptable, which means it's good enough to be a grounding point. Next, we can achieve below 1 ohm value by using grounding enhancement material, which is GEM. Last but not least, we cannot use any chemical grounding because we need a proper grounding chamber. in order to get grounding lifetime around 2 or 3 years. Next, I will continue with the connection between grounding terminal cell to the frequency converter. As you can see, the connection is from grounding terminal cell to the frequency converter as shown in the picture. The kit FC cabinet has a copper foil braid connection for connect the cabinet with low inductance. The standard length of copper foil or braided is 10 meter. Take note to always care that the kit FC cabinet is grounded with the power ground from the input. Thus, to ensure the earthing line is function in a proper manner, we must ensure that the grounding must be very low potential, which means resistance must be low in value. Furthermore, if the resistance is more than the requirement value, there will be inaccurate potential. In example, which lead to improper discharge, such as current will floating. This is because the current will find a path to the lowest resistance. As you can see here, this is the kit FC cabinet connected to the terminal cell via copper foil or braid. It is also connected to current transformer. Thank you for watching.